All right, welcome to part one of the Avi Edge webinar. This is a multi-part series. In this first episode, we're talking about F5's Big IP Next, the discontinuation, and what it means for you. So, hi, I'm Nathan McMahon. I have with me as well Matt Adams.
Yep. Hi, guys.
All right, just making sure he's still there. Okay. Um, so a little bit of an introduction to myself and Matt. Um, Technical evangelist with the technical product management team. For myself personally, I've been with Avi since its inception about 13 years ago. And then prior to that, I was with another startup, a company called F5 Networks, and I was there starting in the late 90s. So a little over a quarter century in the load balancing space. And Matt,
Yeah, if we're doing backgrounds. So
just quick.
I didn't start with Avi quite as early as you, but I've been with Avi, I guess, slash VMware slash Broadcom for 5 or 6 years or so. And prior to that, I worked for a large financial managing their F5 stack. And then, of course, we converted all that over to Avi. So the Avi stack.
That's what. All right, fantastic. So we're going to talk a little bit about the F5 Next, the discontinuation, but which is a pretty straightforward, discussion. But from there, also extend into the differences of what they were doing and what they're not doing, and why this matters to you, and kind of a little bit of a compare and contrast with Avi, and really where the technology is going, where the future is going, and where the future is. So F5 Next discontinuation, we're pretty much going to start at the end of our story, which is to say it's discontinued. Um, I don't want to speak too much for F5. It's, let them speak for themselves a bit. But basically what this is that F5 had been working on this next generation technology, this next generation architecture, trying to move more towards a controller-based architecture. And they quit. They gave up on this. So they recently very quietly announced that this is going away, and we're just not going to go and provide this functionality or capabilities to our customers. This happened just recently here in August. So we want to talk a little bit about this. I don't want to speak too much for F5, but I do want to speak a bit about what this means to customers out there. If I've been touting this, but literally they have a PowerPoint. I'm guessing a number of you may have even seen it or been privy to this, but they had this PowerPoint that they were show customers called the Avi Killer. And it just kind of went out there and showed this architecture of these great things that they're going to be doing, they're going to be building. And they've been out there touting this for as much as 6, 7 years now. They started development of Big IP Next a number of years ago, and then they announced Next last year. And then this year they've already discontinued it. And they're basically telling people, just go back to the drawing board, just go back to continuing using the same 25-year-old architecture we've been using for, since the 90s. There's a couple of little caveats to this, in that with F5 Next, they are going to continue this for some specific use cases like Kubernetes. But for anything outside of that, they're basically saying that they're not going to provide any kind of a modernization efforts around things like an orchestrator-based system. Just to kind of give you a little bit of a, take a step back. When we talk about things like F5 Next, F5 Next was basically F5's next attempt at modernizing the load balancer, being able to provide a more intelligent centralized management, basically trying to tiptoe their way into an orchestrator. F5 has built a number of centralized managers over the years. In fact, if you've got a little bit of history with them, you can go all the way back to the year 2000 when they first released a product called See It as their first centralized manager. And then See It was replaced by Controller IT, which was replaced by Iceman, which was replaced by System Center Operations Manager plugin, which was replaced by, I'm missing a few, Enterprise Manager, which was replaced by Big IQ, which was intended to be replaced by Project Blue, and which was intended to be replaced by Next. I'm probably missing a couple, but somewhere in there's about 8 different centralized managers that they built over the last 25 years or so. So pretty much like clockwork, every 3 years, you see this kind of this timeline of they start some new grandiose kind of centralized management tool, work on it, release it, and then discontinue it. So it's pretty much if you've been doing this for any length of time, you've seen quite a number of these come and quite a number of these go. A little bit about what was or what is F5 Next. F5 Next, this is an example of their architecture that they'd released, and it shows a very similar architecture to what you see with Avi. And Avi's been this architecture's been out and released in the wild and has been in production now for quite some time. I've been with Avi since its inception 13 years ago, so we've been doing this for a fair bit of time. And what you see with this is that this was F5's first real attempt at trying to shift and move from being just a centralized manager into something more of an proactive orchestrator. And it was a really difficult transition to make because they kind of had one foot still in the same legacy architecture, and they're trying to put one foot into this next generation architecture. To put a kind of a bad spin on this, this is kind of like having a candle and trying to turn this into a light bulb. It's one thing or the other. So it's a little bit of a challenge to do for them. And I think this is, conjecture, but this is potentially, part of why it just kind of got discontinued. It was really it's hard to be both at the same time. With Avi, we really started with a clean slate and said, let's start out with a, completely clean slate. Let's build towards a modern architecture. Moving from a centralized manager to an orchestrator is pretty paramount to getting and taking advantage of a lot of these next generation capabilities, integrations, and technologies. And this orchestrator based architecture is what you're seeing with virtually every new modern system out there. Everything from look at things like NSX, you look at things in the world of compute, with things like vCenter. If you look at things in the world of networking, even things like Kubernetes, et cetera, they're all more of a orchestrator. Or you even see in things in the world of AI, they start calling it out choreographed rather than a centralized management. What's the difference between a centralized manager and an orchestrator? Glad you asked. Uh, what you have is, let's take a step back a little bit. What you have with the traditional F5 is you have this active standby pair. And this is going to appliance. I don't care if it's a hardware or software. And this is true for F5, this is true for Nginx, this is true for HA proxy and any other just generic freeware load balancer. It's just a generic active standby pair. And this technology and this architecture has been around for literally a quarter of a century. Um, with Avi, it's done a little bit different, where we have an active-active fabric. So we can have fully active-active service engines, or the data plane component here, and those are all managed by this orchestrator that sits up above this. Kind of an interesting point about this is that these guys are pushing packets, they're doing load balancing. These are your data plane. The interesting thing about these load balancers here, both with an appliance as well as with the Avi service engines, is they're a little bit different in how they do and what they do. But one similarity that you have with them is that both of them are in the weeds. They're the ones that are doing the load balancing. They're in the weeds. They don't have much visibility outside of themselves. In other words, this individual load balancer, this load balancer pair, it doesn't know that it's installed in vCenter. It doesn't know that it's installed in AWS or Azure or elsewhere. It knows nothing about the world outside of itself. All it knows is a packet came in, I'm going to load balance it. And that's its world, that's its job. So it's a very myopic view of the world. Up above the weeds, though, this is why we have this controller-based architecture, which sits up above this, has an overarching view of the entirety of what's going on across this load balancer, but across all of them. And this translates a little bit into the centralized management versus an orchestrator. And this is kind of a critical point is that F5 has always had centralized managers and, kind of go back to things like Enterprise Manager, Big IQ, See It, et cetera. Uh, but the centralized manager is not an orchestrator. And the kind of a difference with this is that in this example here, I've got all of these load balancers or load balancing pairs. Those load balancers have a CPU in them. That CPU is doing the data plane, pushing packets, load balancing, etc. And also on that same CPU, it's doing the control plane services. This is going to be things like having the GUI, SNMP, all of the watchdog timers to determine if things are working, not working. All of this is being handled by that same load balancer, by that same CPU on it. As an administrator, you're logging into this, you're managing this. If you want to introduce something like a centralized management, then what's going to happen is that load balancer is still a complete island of technology by itself. So you can log into this load balancer, make configuration changes to it. The centralized manager is then going to go out and make configuration backups from all of these active load balancers that you have running around. So you can log into the centralized manager and see the world from its viewpoint of all of these load balancers. But an interesting point here is that if you want to make a configuration change at the centralized manager, the centralized manager is basically a UI pass-through. It's taking that configuration change and then pushing it out to this load balancer. But you can also go directly to that load balancer and make that configuration change. So you have some interesting scenarios where you have race conditions, where this guy, the centralized manager, is not truly in charge. He's simply a UI pass-through to whoever is in charge, which is the load balancer. If ever there was a discrepancy between the configurations, this load balancer is the running config. And so what happens here is because you have these race conditions, you have this where the centralized manager is not truly ever in charge. And so therefore it can't really take a lot of proactive make proactive changes. It's not, it doesn't govern things. With an orchestrator, it's done a little bit differently. With an orchestrator, we have all of these load balancers, in an obvious case, these service engines that are operating at the data plane level, and they're pushing packets doing the thing. But again, they don't have a view of the outside world. They don't know anything about where they're deployed or about anything that's going on outside of them. They don't know that they're 100% busy, but their neighbors are only 50% busy. They don't have that a strict view of this. However, the orchestrator above them does. An orchestrator is different than a centralized manager in several ways. One of which, the orchestrator is the source of truth. It is the intelligence. So rather than having all of that control plane and management plane intelligence on each and every individual load balancer, that intelligence is pushed up here to the orchestrator. So the orchestrator is not a nice to have. It is the brains that's controlling the arms and the legs. And this model over here, what you have is you have a bunch of cats running around doing things, and you've got a centralized manager that's trying to tell you what happened to those cats and which direction they all ran. So with an orchestrator, though, if ever there's a discrepancy between the configurations, the orchestrator is the source of truth. It's the one that's in charge. It's the one that's pushing that config down to the service engines, not the other way around. So as an administrator, you log in, you tell the orchestrator the outcome you want to achieve, and the orchestrator can achieve that for you. Think of this as hiring a load balancing intern, saying, go and manage my fleet of load balancers. And if everything is okay, job well done. If there's a problem, then come back and tell me. So in this example here, as an administrator, you just say, I want to go and create this virtual service. I don't tell it which load balancer to put it onto. The orchestrator can figure that out. It decides which service engine to put it onto. It just figures out which one has capacity now. It's also looking back over time at a history to say how busy is it over time, which one has the right VNix plumbed into the right port groups, which one has enough memory, which one has all the way down the line. So that way, as an administrator, I don't really care about the details. I just want to deploy my app. What if I have too many concurrent connections? What if I exceed the capacity? The orchestrator's job is to take care of that. It takes care of all of the networking, all of the infrastructure below me. In this other example, you're completely, as the administrator, you're completely in charge of all that. You're responsible for each and every one of these kind of decision trees. Which load balancer do I want to place it on? Which one do I want? Now, the problem with this is that as you get into this, if I have 100 load balancers in my environment, then I'm still managing 100 devices. In this example over here, I'm just managing one load balancing infrastructure. Is it large? Is it small? It's one infrastructure. So kind of a little bit of a, what we're looking at. Where do I want to place this? What do I want to do? What if I have too many concurrent connections? What about snap port exhaustion? In this example over here with an orchestrator, with the Avi controller, I don't have to deal with this. That's the point of this, is that the orchestrator's proxying is dealing with all of that for me. And this is a little bit of the where F5 was trying to tiptoe into and try to move from being a centralized manager to being an orchestrator. But that one of the core challenges of doing that is that all of the management is still done at each individual load balancer. So you kind of run into some fundamental flaws here where if you don't change up the existing infrastructure, if you don't change up that existing architecture from 25 years ago, it's really hard to move into a modern architecture. The most you can do is try to band-aid this a little bit and make it look closer, but under the hood, it just never is. So as a centralized manager, it really is more configuration backups, UI pass through. You're going step by step through each and every bit of this process. With an orchestrator, it's a proxy that's managing your load balancing infrastructure for you and presenting to you and saying, here's load balancing as a service. It is the active source of truth of the configuration. It's the brains that controls the arms and the legs. It's the only point of control. It's sitting out of band and it's doing machine learning and analytics. It's able to ingest as many as 700 different metrics from every virtual service and translate from raw data to actionable information because it is the source of truth. It has all of the information of what's happening and it sits out of band. So it can grab all of these metrics. We're not going and doing all of this hardcore AI machine learning on each and every individual load balancer. Instead, because those are doing their CPU is busy doing data plane pushing packets. Instead, we're doing this on the orchestrator out of band. And again, it's abstracting away the network so that you don't necessarily have to deal with all that. You tell it once how you want it to behave and then let it run. Is it one service engine underneath it? Is it 100? It's functionally the same. It's the same amount of work. So instead of a manual process, it's intent-based. Just kind of some benefits of an orchestrator. And the reason why I kind of call this out is that these are a lot of the benefits that F5 was touting that you're going to be able to get by F5 moving more towards an orchestrator-based architecture. And now that they're basically saying, yeah, we're not going to be able to do that. It's too much work. It didn't work out very well. We can't go and change up the existing big IPs and the existing load balancing infrastructure. And so what this translates into is these are things that you're not going to be getting because F5 is basically walking away saying, yeah, we're not able to provide this for you anymore, which is a pretty heavy retreat. Single point of control. I'm managing one load balancing infrastructure, not hundreds of individual load balancers. An ecosystem integration, which is absolutely critical. That controller, in this control plane architecture, the orchestration, my people talk to your people. My orchestrator talks to the compute orchestrator. It talks to the networking orchestrator. So the Avi controller talks to vCenter. The Avi controller talks to NSX. It talks to VCF. It talks to AWS, all the way down the line. That integration is absolutely paramount to being able to get to uh, self-service and to get to some next generation capabilities. And we'll talk a little bit more about some of these analytics, autoscale, self-healing. To kind of give you a little bit more of a visual example of why this matters, what an orchestrator can do versus dropping back to, yeah, sorry, you're going to have to just stick with being a centralized manager for a while. An example of every modern architecture nowadays, if you're looking at public cloud, if you're looking at VCF on-prem, if you're looking at anything, it's all moving towards this multi-availability zone architecture. Why this matters is that each AZ, you take a traditional data center and you carve it up into three virtual data centers. And that way, any one third of the data center could go down. That's okay. We still have high availability. We're still up. We're still working. Each AZ is separate power, separate top of rack switch, separate routers. Separate routers means separate IP space. What that means is I have three availability zones. Each AZ has different IP space. So if I deploy an active standby pair of load balancers and I'm highly available, that's great. They have a VIP. They're propagating out to the outside world. If that availability zone goes down, if that load balancer goes down, you're down. Simple as that. But it doesn't matter. You're down. What you should be doing is that you should be taking your application, striping across all three availability zones, and then deploying a load balancer in each AZ. So in this example here, I'm deploying one service engine in each availability zone. And each of these are then going to replicate the configuration. Each of these then needs to have an IP address because we need a VIP address. But since it's different IP space, we have three separate IP addresses, three separate VIPs. So I have three VIPs or three virtual services. And then each of those are going to propagate that out upstream into DNS to send or direct traffic inbound. And then if one of these availability zones fails, then that's fine. We simply remove that and deregister that from DNS and use DNS to direct traffic to the available AZs. But the interesting point about this is that I'm not managing three load balancers. I'm not managing three separate virtual services or three VIPs. Instead of managing one application, one virtual service that happens to have three listeners on three different IP addresses. And these three, so I'm managing one application, one virtual service that's striped across three load balancers or three service engines, has three separate VIPs. They're going to be doing things like mirroring and replicating the persistence tables. It's like a source IP persistence if you're using that. They're going to be replicating things like SSL or TLS tickets. So from your perspective, you're managing one application or one virtual service that happens to have three listener IPs. It actually gets more interesting when you multiply that by IPv4 and IPv6. So now it's six IP addresses. And it gets even more interesting if you do something like a virtual service that's listening on port 80 and 443. And port 80 is just doing a redirect. If you're using a legacy load balancer like this, you would actually, to do this legitimately and do this correctly, you would have to you'd have to create 12 separate virtual services. So when you start talking about config drift, for one application, you have 12 virtual services. In Avi, with this more modern architecture, I just want to have one application I want to deploy, and I want it to be highly available. Is it IPv4, v6? Yes. Is it striped across three AZs? Yes. Is it port 80 and 443? Yes. But it's one application, one virtual service. And that's an example of just, if you're using something like an F5 or an H8 proxy or anything, just kind of generic like that, you have to create 12 virtual services. On Avi, it's just one, and it's seamless. It's intelligent enough to understand the ecosystem around it, to register and deregister these IP addresses into DNS. And if that's using your own DNS, if that's propagating that into Route 53 or something else, that's the point. Let me turn it over to Matt and have him take over and talk for a bit.
Yep. Okay. Can you guys see my screen okay? Can you guys see the screen okay?
Yep.
Awesome. So I wanted to address one question we had in the chat first, and then I'll pick up here. So are there any field-facing competitive calculators against F5? Yes, we do have a number of them available. Please message me, Matt Adam, and happy to see how we can get you access to it. Okay, so thank you, Nathan. On to point number 2 of why an orchestrator matters. The self-healing fabric. When a load balancer goes down for any reason, it would be nice if a new load balancer could just be stood up in its place, right? That's really what a true orchestrator will provide for you. An orchestrator not only knows where all of its load balancers are and their health status, but also how to spin new ones up in whatever environment they're currently deployed in. So as you can see, we have 3 different load balancers here running in tenant 1, and um, you can see through the animation, and the third load balancer basically fails. Avi will automatically spin up a new load balancer, plumb all of the backend routing, and start processing that load balancing traffic. You don't have to do anything manually. This is all done for you via the orchestration. The load balancers are deployed with anti-affinity rules in place, so we're not going to put them, on the same ESXi hosts in the background. Everything's going to be spread across different hosts for fault tolerance. And once the new load balancers are up and running, we'll automatically move over the application traffic to the new instance, um, uh, basically all in the backend for you. So pretty cool, right? This is just another added benefit of the orchestration piece. Well, there's more. So if you look at the third reason here, it's for flexible upgrades. Flexible upgrades. Before my time at Avi, and again, I've been here for 5 or 6 years. But back when I was at the financial, we were a very heavy F5 shop, hundreds of F5 LTMs and GTMs. It took us months to upgrade all of those LTMs and GTMs. And during an upgrade or patch cycle, we often expected delays or sometimes problems from it. There were just so many upgrades to do, so many different devices to do. And we had to wait for change windows, application validation, etc. It was a very long process. So when we brought Avi into the picture, many of those problems were resolved. We reduced our management device footprint significantly. We were able to upgrade hundreds of load balancers with ease. And in Avi, the upgrade is quite literally a single operation. You log into the controller, you upload the upgrade package, select whether you want to perform the upgrade or maybe just perform a dry run, and hit go. That's it. Avi will upgrade the controllers, and if you want it to, it will automatically go out and upgrade all of the load balancers. Whether you have 2 or 10 or 50 or 500, all of them will get upgraded in a sequence. It does this in a non-disruptive active-active manner, since all of the applications are essentially scaled out onto multiple load balancers at the same time. Avi also has a rollback built in. So if a problem happens during the upgrade or after, you can roll the code back to a previous state with the click of a button, essentially upgrading your critical load balancing infrastructure. Sorry, I saw some message in the chat. Again, upgrading your critical infrastructure has really not ever been so easy with the advent of orchestration and Avi. Moving on to self-service, which is the fourth reason on why an orchestrator matters, automation and self-service. For those of you that are on an automation journey, maybe you're just starting out, or maybe you already have some workflows, or maybe you have full end-to-end self-service offerings. The feedback we hear most from customers is that they want an easy-to-use load balancer that can integrate with their existing DevOps tools. Avi is that solution. So Avi is built for self-service and automation. The platform is 100% API driven, so anything that you would do through the CLI or the UI can essentially be done via the API as well. We have SDKs available for pretty much most of the common programming languages, and of course we easily integrate with VRA, or also known as VCF automation, for self-service load balancing. We'll actually look at that here in a moment. We're well integrated into NSX and vCenter, so we perform discovery and the overlay. We can deploy new load balancers in vCenter and attach port groups or segments directly to the load balancer as needed. A lot of this is kind of what Nathan was talking about. The benefit of the orchestrator is that you don't have to do this. You don't even have to know these concepts. All of it's done for you automatically out of the box once the cloud's connected. We also have integrations into VCF itself, and we'll talk about those in a couple slides. But even outside of the VMware components, Avi can manage the IP space for your applications, automatically assigning them new IP addresses when they're created. Avi can integrate with your DNS provider to register FQDNs when new apps are spun up. We can integrate with your certificate authority, whether it's a public or private CA, we can integrate with them, manage the lifecycle of certs. This is especially important as we move toward the what was it, 46-day, 47-day certificates? Forgot the exact date. It's coming up quick. Within a couple of years, we'll be at 47-day certs, I believe it is.
Yeah.
47. Okay, I never get them. It's such an odd number. I'm
It's
sure
not a
there's.
number, but there's the short version of this that instead of renewing your certificates every year or every multiple years, you're gonna be renewing them every other month. You're gonna be renewing your certificates. The only way to do that is automate that. And to do
Yes,
that, my people talk to your people. Automate this. Have the controller talk to your certificate authority. Problem solved.
absolutely. And so there's a whole other benefit that I just put on the screen here about Central Manager, and this is the analytics and logging that you're available to view from a central place. So the network teams, even the application teams, they can all view their application logs and their application latency, or even troubleshoot their own applications all from a central portal without having to play the guesswork of, which load balancer was that application running on. So hopefully you understand the value of an orchestrator versus a central manager. Let's pivot just a bit into VCF. So Avi's plug and play with VCF. Looking at the standard build, operate, consume, and protect model, with build and operate in mind, we integrate with the components of VCF, specifically with the build and operate for VCF ops, or also known as VCF operations. You can deploy Avi into into your VCF environment with just a few clicks. And VCF will manage all of the lifecycle components of Avi, including password and certificate rotation. On the consumption side, as we had just talked about, we are well integrated into VCF automation, also known as RE automation or VRA. From if you've been using the product for a while, it's gone through a few different names. But you can deploy Avi into VCF and use VCF automation as a self-service portal to essentially allow your app teams to create applications. So all that hard work, of the backend orchestration is going to be done for you behind the scenes with our integration. On the protection side, Avi has a built-in WAF for your standard workloads, and on the Kubernetes or container workloads, we again have available built-in security. It's very easy to deploy to your applications as well. A couple clicks, and your application can be protected from various attacks in the OWASP top 10, and more. Avi also has built-in DDoS and botnet protection, or rather bot protection, which provides added security for your applications. So as you can see, Avi is well integrated into the VCF stack and is quite literally plug and play for the components. Okay, so if we look at the orchestration layer, from the infrastructure persona, there's a day zero deployment of Avi, of Avi into VCF. A few a few clicks of a button, and then basically Avi's deployed via the SCDC manager, integrated into vCenter or NSX if you're doing the overlay, and the various lifecycle components are going to be managed for you. VCF automation is essentially the automation and self-service component. So your DevOps teams are going to write code and create integrations into these components and use this layer as a way to quickly deploy their applications and any of the required load balancing. And at the very top, we have the app owners themselves. Um, they will be isolated to see only what is going to be available for them in their tenants or VPCs. And with Avi, they're going to have access to those extensive applications and log insights and HTTP logs, showing them exactly what their applications are doing now and historically. So we won't have a ton of time to get into the analytics, but I would encourage you, if you're curious to see what type of analytics we have available, go look at a demo of Avi and see how well we integrate into VCF, and of course, see what level of insight we can provide to your app teams. So if we look at the journey over the years, we've continued to improve our integration with VCF. We have had integrations with vCenter and NSX for many years. Nathan, probably since the beginning, I'd imagine, but at least as long as I've been using it, 8 or 9 years. And much of the development over the past year or so has been furthering the integrations with VCF itself. So in 5.2, we introduced an integration to easily deploy Avi, the Avi controller, directly from the SCDC manager, as well as tighter integrations with VRA, so VCF automation for the various self-service deployments, and then of course application analytics. In 9.0, we introduced support for tenancy and VPCs. So, as well as the VCF import. And we've further enhanced our integrations with VCF automations. In the future, you can expect that you can expect even tighter integrations with VCF and its components. As they have new releases, we're going to be in sync with them. That's part of the perk of having, two different products, but under the same hood. Okay, so in summary of VCF, and then I know some of you really are excited to see the demo, so I think there's one more slide and then we'll jump to the demo. But here's a summary of Avi and VCF and the integrations we have. So on the left with deploy and operate, again, you can see that Avi, it's very easy to deploy Avi into VCF with just a few clicks. VCF will handle the lifecycle management pieces, and this will make this quite literally will make the life of a VCF administrator much easier. They don't have to worry about managing those passwords and certs for for these infrastructure items. In the middle on consume, we are integrated for tenancy and VPC support, and your app teams, uh, essentially DevOps teams, are going to love how easy it is to deploy applications via the self-service offering. And lastly, on the right for application visibility, we didn't get to spend a lot of time on this, but again, this is one of our strongest selling points. We provide full application visibility, end-to-end latency for each of your applications. And additionally, we rate the applications with a health score based on the traffic streams that we gather and the built-in HTTP level logs that we have that are easily searchable and easy to integrate and extract so that you can you can use these logs for troubleshooting application problems. Now let's take a deeper look into the VCF automation piece. Okay, so VCFA, VCF automation, VRAs, again, it's been through some different names, but on the left side, we're looking at a screenshot of VCF automation. This tool allows app teams and developers to use self-service forms in the catalog to deploy various things, including applications for load balancing. So the beauty of this is that it really takes the complexity away from the app owner. You can create a form that just asks a few simple questions, questions that the application teams will know, like what is your application name, what type of application is it, etc. They click go, and the orchestration will do all the heavy lifting. So deploy the load balancer, register the DNS, get a certificate, firewall if required, et cetera. Anything else that's going to be required, it's all part of the orchestration layer in the backend.
The
So
cool thing about this is that this is abstracting away. You pre-build this, then you have my orchestrator talk to your orchestrator all the way down the line, and it's literally just point and click to set that up. And now from an application owner perspective, they're not exposed to any of the networking behind it. The networking is happening, but they're not exposed to it. That's the
exactly,
magic of all this. It's pretty cool.
exactly. All right, so let's take a deeper dive into VCF automation with a short demo. Okay, so let's create basically an application. We want to create a self-service portal and offer this self-service portal to our application teams. First, we'll look at a simple L4 example. We're going to basically just create a very simple workflow to create an L4 application. And you can see in the screen here, we're basically going for a VM create. We're configuring the VM class. We're configuring the image we want, which is the Ubuntu. And then click a couple forms, and then we're going to select the information for the load balancer. So very simple, again, just port 80, HTTP, we're just going to run this through L4. And then we connect into Avi, the Avi load balancer. On the right-hand side of the screen, you can see all of the easy-to-use YAML. This makes it great for scaling in the future. So do this as a one-time operation to get the code, and then you've got the YAML for the future. A couple clicks of a button, and we have a load balancer deployed in Avi, right? So onto the more complex example, we're looking at an L4, L7 solution from the perspective of a cloud admin. There are some steps that we'll do first to create a blueprint, and that's what we'll look at right now. And this is kind of that back-end work that Nathan and I were talking about. Some of the back-end work is done within Avi as the orchestration piece, and then some of it is done within VCF automation for creating the blueprint. So what we're doing right now is quite literally dragging and dropping some of the various components of the blueprint. And we're basically developing a manifest. This is what we want our app teams to use when they create their applications. And so on the right side, all of the YAML is going to be populated for you. This makes it very easy, again, to reuse lots, segments of this code or all of the code. And we're going to use some of the code that we generated previously, put it in the right side here, and then we're going to save this blueprint. And then this blueprint is good to use. We're going to create a self-service form for this blueprint and essentially use it to deploy an L7 application. And you can see none of this was really that complex. It was all kind of drag and drop, a couple of variables on the right side, but nothing was that hard from the administrator perspective to set up. And then when we look at the DevOps persona, so again, this is going to be the user of self-service. They click on the form. They don't have complex questions. What's your application name? What port? Do you have any special things? Do you want a certificate? Just a few pieces of info. They click submit. It takes a few seconds on the VCF side, and then the load balancer is created. So you can see the application there, and then in Avi, you can see the load balancers deployed here, along with all the analytics and logs.
So load balancers were installed, they were connected, the port groups are connected. I don't have to worry about things like the order of intermediate SSL certificates. I don't have to worry about snap port exhaustion, et cetera, et cetera, et cetera. My application's deployed,
Exactly.
which is pretty cool.
Yep. True self-service, true end-to-end self-service available out of the box. Okay. So let's pivot just a bit and talk about how you can move from a legacy load balancing vendor like F5 to Avi. Okay. So F5 continues with multiple products that they were working on, the orchestrator to kind of stop that approach. So they're back to multiple products. You have LTMs for local site load balancing, GTMs for multi-site, ASM for WAF, etc. Generally all of these are separate components requiring separate licensing, separate management, lots of different work to get all of these integrated. With Avi, all of it is in essentially one license: local load balancing, multi-site load balancing, Kubernetes ingress, WAF, container security, application analytics. All of it is built in for one license. This is going to make it easier for you to consume and deploy the product. And on the topic of consumption, we make that easy for you as well. We have something called a converter tool. It's called the Avi converter tool. We call it ACT for short. This is not a new tool. It's actually been around for I'd say 7 to 8 years, maybe even longer. So it's well established. In fact, we use this tool at the large financial that I worked at, and we migrated tens of thousands of applications from F5 over to Avi using this tool. ACT will look at the existing config so that it'll get the existing F5 config, import it, review it, and automatically convert it over to Avi. There's an easy to use GUI interface, which we'll see a short demo of it just in a moment, but the tool will convert not only the config, but also the iRules. So what we found is that, from looking at many different customer environments, most of the iRules don't need to be iRules at all. So oftentimes they're simple redirects or content switches to different backend pools or pool members. We do that natively in Avi without complex scripting. But in the event that there is a complex rule, we do have a scripting language available for those more complex iRule conversions. Let's take a look at the difference. So, on the left side, short and sweet, a complex iRule. But I'm not even sure what it does. I'm sure if I took a couple seconds to review it, we could see what it does. But a typical TCL-based iRule. And on the right side, a simple Avi policy, right? These are drag and drop. They're very easy to set up. In this case, it's got 2 different rules, a simple match on the path, sending to a different backend pool member. this would have been a dozen or so lines of code in TCL. This is all configured with just a couple clicks of a button in Avi, mostly drag and drop. So you don't have to know any scripting language or have to worry about syntax mistakes whenever creating these types of policies within Avi.
And
Okay,
so the config converter can just go and suck those iRules in and convert those to things like policies. Um,
exactly.
and if you needed to, then yes, you can still write complex rules on Avi as well. But hopefully you shouldn't need to is the goal.
Exactly. We do have a scripting language built in, as I mentioned earlier, but oftentimes when we see these types of conversions from F5 to Avi, 70% of them or so end up being a policy, maybe even a higher percentage than that. They end up being a policy because the native way we do it in F5 was not native to F5 without a custom script.
Cool.
Okay, so let's see it in action without any further ado. All right. So let's look at the converter. We're gonna go through iRule conversion. We're gonna look at the configuration, and then we're actually going to apply this directly to an Avi controller. So first is just kind of that day zero setup. You specify your Avi credentials, your F5 credentials, let it do the import. After the import, basically you can see the configuration we have. So iRules on the top right. These are iRules that we've discovered and converted. One of them is, something's going on with this iRule, needs to be reviewed. You have the option to review it or modify it. In this case, we'll just skip it so we can proceed on with the migration, and we'll continue to the configuration. So now we can see side-by-side comparison of the config. Very simple. We've converted it for you. You don't have to worry about the complexity. Now is really the last step. We have all of the configuration for you. Generate the YAML playbook so that we can push this to Avi. So a couple clicks of a button, we're going to create the YAML playbook. And then the very last step is deploy to the controller. That's it. This whole thing, we migrated an application from F5. This would have normally been, from experience, a good hour or two of work, looking through, making sure the TCP profiles matched up, the HTTP profiles had the right settings, that they even existed in the new controller. All of that's done for you. It's a very quick approach. Now, of course, this was a very short 1 minute video, but from experience, these types of at-scale migrations, you can move a few hundred VIPs in a weekend. You can move considerably more than that if you uh, are brave enough.
And
Um,
it's also interesting too is that it converts this into YAML, and it's from that makes it super easy to go and pull this into things like Ansible and take advantage of automations like this as well.
Absolutely. So we've had many customers use the converter tool, over the years to migrate from F5 to Avi. I'm a walking example of this from a large scale migration at a financial. Tens of thousands of apps use this tool to convert from F5 to Avi. But here's another example of a customer that used the tool, migrated a pretty significant workload as well. So 1,900 virtuals, 466 iRules. That's a lot of config. This would have been months and months and months of work to do manually. Thankfully, with the ACT tool, this project was more or less prepped within a week and migrated at the convenience of the networking teams. This customer can now enjoy the benefits of simple and flexible upgrades, reduced management, reduced footprint. They're going to save money on the OpEx side. All of this made simply because they were able to move the configuration quickly from F5 over to Avi. So hopefully you can see the benefit of the converter tool. It's available today. Many of your customers are using it. Using it to migrate from F5 to Avi. We have other supported vendors as well. And so if anyone's interested in using this, happy to have a discussion with them on how we can get started. So with that, we've got a couple questions before I hand it over to you, Nathan. Let me look at the chat real quick. Which side we have to deploy the ACT F5 environment or Avi?
So you can deploy this onto any Linux system. This is just a tool that you can go and drop this onto your own in your own environment, and then from that, the ACT will then a couple ways you can do it. You can have it actually reach out to and connect to your F5 devices and connect to your Avi devices, or you can take the F5 config and you can drop it onto it. So You can have it, give it directly, give it access, or you can just manually drop the big IP.conf file on either way.
Yep. And two follow-ups from that is, can this done by engineering teams, and is this basically free to download or inbuilt with Avi? So it is not inbuilt with Avi. It is free to download if you have. I believe you have to have Avi or the correct entitlement, but it should be downloadable today. And yes, it's something you guys can do in-house. It's something you guys can do on-prem. It does not require our resources to do this migration. How is Avi integrated with Service Mesh? So we have a couple integrations with Service Mesh, but most notably, we can basically front Istio. So as Istio is running in the mesh, we can support, but basically, that MTLS spiffy cert on the service engine, so that we can get that full integration into the KAIDS cluster. We have a couple customers that have that deployed. If you're interested in that, Thomas, we can get you a demo of that. Chris Grice is probably better suited to do that demo for you, but we do have a pretty robust integration there. I think that was the last.
There's one more question. Can Avi
Okay.
coexist with F5 in a hybrid strategy, or is it intended as a full migration? You can just migrate over a virtual service at a time. We don't expect you to go and migrate 1,000 virtual services in one operation and good luck. Hope it all works. Generally, you're going to kind of dip your toe in. So using that conversion tool, you can just move a virtual service at a time and test it out, get comfortable with it, get a feel for it. And then, the more you're kind of used to this, the faster you'll go. So it absolutely can, and we expect it to be in kind of a hybrid, model as you're moving apps over. But the point is, we're very much usage based. Like, kind of like a couple things to take a step back. If you look at like F5 and kind of the appliance model, that salesperson is selling you a box, hardware, software, but they're selling you that, and then they've already made their sale, they walk away. With Avi, the Avi model is based upon consumption. We're basically, the more that you use of Avi, the more CPU cores. That's how we're licensing. So the more CPU cores you're consuming and using, then the more that we're charging you. So we're based upon usage and consumption. And what that means is that we want to make it as easy as possible for you to use Avi. That's why we do things like we offer free trainings. That's why we do things like make it really easy to migrate the configuration over. And because the more applications you're deploying on Avi, then the more you're consuming it. So we want to make it as smooth and easy a process for you as possible, rather than sell you one large box up front and then walk away and talk to you again in 5 years. So it's
Yep.
just a different business model.
So Nathan, before we answer any more, let me hand it back to you to take us home for the closing, and then we'll open it up for Q&A.
Okay, so just a couple of key takeaways. So the F5 Next is discontinued. That's kind of straightforward, and but it's what that really means for you is that a lot of their efforts into trying to provide this next generation orchestration integrations with the ecosystems and environments, and really moving the world towards this kind of concept of self-service, load balancing as a service. And they pretty much have just kind of stepped back from that. And a lot of the marketing and things that they talked about with that, they're kind of have gone quiet and gone dark on. They're basically saying, just go back to what you've been doing for the last 25 years and pretend like there's nothing else out there, that there's no better way to do things. You're going from all the advantages of what an orchestrator can provide back to a centralized manager. If you go all the way back to the year 2000 when they released the first one, see it. It hasn't changed a whole lot since that version in 2000 to what they're offering today with things like Big IQ. There's not a whole lot of difference there. And technologies move forward, dramatically move forward. And hope that example of self-service and what you can do with things like VCF, that's the direction of where technology is going. If it's on-prem, if it's public cloud, you name it, technology is moving forward. So to be going backwards in technology, yeah, I mean, as a customer, that's a little bit offensive. A great example of using Avi plus VCF and where the direction of technology is going. How you can take advantage of the fact that Avi's integrating with the ecosystem around it. And it's not just, VMware plus VMware tooling. It's also Avi's talking to and tying into and integrating with DNS, with SSL, with your IPAM, with all of these adjacent services to provide that integration, which is what's pretty amazing. You have to, yeah.
Okay.
It's the next steps. If you want to learn more, we do have webinars where you can go through and do a hands-on labs in a webinars. It's kind of a 60-minute version of this. There's also more advanced workshops that myself and my counterpart elsewhere around the world will offer. And these are going to be multi-day classes where we deep dive into the technology. So if you're interested, hit that QR code on the right, and it's definitely something where you can get a heavy dose of me. The nice thing is that I don't have to be quite as polished and as politically correct, so I'll tell you what I really think. But it's a deep dive into the architecture, into the weeds of how to take advantage of these integrations and how to make this happen. There's additional edu courses, even custom workshops if you're interested in this. So take advantage of the fact that we do have free trainings that are available. We do have things like free labs that are available you can directly drop into. So take advantage of these and get yourself, get your feet wet a little bit in what we can do for this. Cool. So there's a pretty strong enablement path. If you want to learn more, know more, feel free to reach out to us as well. If you do have any follow-up questions as well, I would encourage you to hit us up at learnavi@broadcom.com. So down here in the kind of top bottom right corner, learnavi@broadcom.com, and that'll hit myself and my team. So if you do have follow-up questions after this, we'll try to address your Q&A questions here now. But if you do have follow-up questions on where to get started and what to do next, by all means, feel free to hit us up. So this is the first in the series. We do have a couple more coming up on October 16th, November 19th. So by all means, feel free to join. Those ones are not Matt and I, so they'll, I don't know how good they'll be. But I do want to say before we actually close, I do want to say thank you very much for listening. I hope you learned a lot. I hope this was interesting and instructive. So thank you very much. And we'll try to hit up some of the questions in the Q&A if Matt didn't already get to them.
Yeah, so I think one of them was about road mapping. Happy to have a discussion with you guys on that. Obviously, but, under NDA, if you're interested, reach out to your field sales team and have them reach out to me, and then we can talk about kind of what we're building strategically over the next 3 to 5 years. And oh, and of course, as Lay had mentioned, to join our TAM, so or rather TAB, the Technical Advisory Board, a great way to get kind of a privy into what we're building in the future. I
Yeah,
think
by
that
all
was the
means,
only
yeah, join
question
the
I
Avi
saw.
community, and feel free to interact with us there as well. Thank you very much.